Okay, so this video covers compound measures, so anything such as pressure, force and area, speed, distance and time, density, mass and volume. So this first question, so these are all non-calculated questions here. The first one states that a box exerts a force of 140 newtons on a table. The pressure on the table is 35 newtons per meter squared. Calculate the area of the box that is contact with the table. So they give you the formula here in this box, and they're saying that the pressure equals force divided by area. So I need to work out the area of the box that's in contact with the table. So let's rearrange this so that the area is the subject to that formula. If I rearrange it, I end up with area equals force divided by pressure. So basically I can multiply both sides by area and then divide both sides by pressure. So I end up with this formula here. Then I'm going to check the units here. Well, the force is in newtons, the pressure is in newtons per meter squared, so they're consistent units, and I need my answer in meters squared here, so I'll just divide them through and I'll get an answer of 4 meters squared. And that question there is worth 3 marks. So question 2, Gary drove from London to Sheffield, okay, and you've got the amount of time it took him and the speed. Then you've got Lynn drove the same journey. She took 5 hours. Assuming she did the same roads as Gary and didn't take a break, work out her average speed from London to Sheffield, and that's in kilometers per hour for 3 marks. And there's a reasoning question for the second part of the question as well, so a total of 4 marks. So let's do the first part now. Okay, so what I'm going to do to break this question down, I'm going to underline the key information here, which is the time it took Gary, the speed he drove at, and then the time it took Lynn. Okay, then using this information, I'm going to find Gary's distance because I've got his time and his speed, and then once I know the distance, because Lynn drove along the same roads, then I can find from the distance and her time, I can find her speed. So let's do that now. So first of all, Gary's distance, well, distance is equal to speed multiplied by time. So if I substitute in the speed of 80 kilometers per hour and the time of 3 hours, that gives me the distance of 240, and that would be in kilometers because this is kilometers per hour, and I've times it by hours. This is in kilometers now. Okay, the part 2, I'm going to find her speed. Well, since I now know the distance she drove along and the time it took her, if I can divide the distance by time to find her speed. So 240 divided by 5 would give me 48. Now the units for this, well, I need it in kilometers per hour, and I've worked out this distance in kilometers. The time is in hours, so that is definitely in kilometers per hour. The second part of this question states that if Lynn didn't drive along the same road as Gary, explain how it could affect your answer to part A. Well, if she didn't drive along the same roads, clearly the distance could be different, right? And if the distance was lower, then her speed would be less, okay? Because she'd have to travel less distance. Okay? If the distance was greater, she'd have to travel faster, okay, in that same given time. So that's the kind of answer you'd want. And again, that's 1 mark. The whole question there is worth 4 marks. Question 3. I've got a plane which travels at a speed of 213 miles per hour. Work out an estimate for the number of seconds the plane takes to travel 1 mile. So an estimate for the number of seconds the plane takes to travel 1 mile is worth 3 marks. And it's an estimate, remember. And the second part is a reasoning question about whether I'm underestimating or overestimating. So in this question here, okay, what I'm going to do is I'm going to use the fact that the time is given by distance divided by speed. So time is distance divided by speed. But I need to be really careful here because this is given in miles per hour and I need my time in seconds. So this in hours is distance divided by speed. Okay, so distance is 1 mile divided by that speed. That'll give me in hours. If I'm going to work this out into minutes, I need to multiply this time by 60 because it's 60 minutes in an hour. I then need to work it out in seconds, I need to multiply it by 60 again, because there's 60 seconds in a minute. So as it's an estimate and it's a non-calculated question, for the distance I can keep that as 1 mile. For the speed, I'm just going to round this to one significant figure, which would be 1 over 200. So 1 over 200 times 3,600. That's the same as 3,600 divided by 200. 3,600 divided by 200 is the same as 36 divided by 2, which is 18. Because this factor of 100 would cancel this factor of 100. So the answer is 18, and that would be in seconds. And let's just check, is this a sensible answer? 18 seconds for a plane to travel 1 mile. Yes, it's a sensible answer. Part B, is my answer an underestimate or an overestimate? Well, if you remember here, what I've done is I rounded down from 213 to 200. Okay, so because I've rounded the speed down, okay, I've assumed the plane is actually traveling slightly slower than it actually was. So this time here is probably actually slightly longer than what it should be. Okay, it would actually take this plane less time. So that's what I've got as my answer here. Since the speed is rounded down, this time is actually an overestimate. In real life, it would actually take less than 18 seconds for the plane to travel 1 mile. The whole question there is worth 4 marks. Question 4. A car travels for 18 minutes at an average speed of 72 kilometers per hour. How far will the car travel in those 18 minutes? And in part B, David says that 72 kilometers per hour is faster than 20 meters per second. Is he correct? So part B is involving conversion of units. So with part A, well, we know that the distance is given by speed times time. So let's underline the key information, and then let's use this formula. Distance is given by speed multiplied by time. The speed is 72, and the time in hours is 18 over 60. Okay, 18 over 60. I cannot just use a time of 18 because that's in minutes, and this speed I'm using is kilometers per hour, so I need a consistent unit. Okay, so because this is in per hours, I need this in hours as well. So this fraction here, I can simplify this fraction since it's a non-calculated question. I'm going to simplify this fraction. If I divide the top and bottom by that factor of 6, I'll get 3/10. Okay, so I simplify the fraction. Now I can do 72 times 3, which is 216 as shown here, divided by 10, and that's the same as 21.6. And the units are in kilometers. Okay, and let me just check. The speed here was in kilometers, so that makes sense, and that will be 2 marks. Part B. David says 72 kilometers per hour is faster than 20 meters per second. So I need to convert 72 kilometers per hour into meters per second. I need to compare these two with consistent units. Okay, so you can either convert this into meters per second, or you can convert this into kilometers per hour, and it doesn't make a difference which method you prefer. Okay, so let's convert this down. So to convert this, well, 72 kilometers per hour, okay, if I multiply that by 1,000, that turns this into meters per hour. So this will be 72,000 meters per hour, because there's 1,000 meters in a kilometer. Now, I've turned that into meters. That's a good start, but that's currently meters per hour. I need to get into meters per second. So to get into meters per second, let's turn it to meters per minute, because there's 60 minutes in an hour. So divide by 60. Okay, so divide that by 60, I'll get 1,200. And now let's turn to meters per second. So again, let's divide it by 60, because there's 60 seconds in a minute. Divide that by 60, and that is 20 meters per second. Now, David stated that 72 kilometers per hour is faster than 20 meters per second. Is it actually faster? No, it's not faster. It's exactly the same. It's exactly the same. So that is 2 marks for that question. And the entire question there is 4 marks. Question 5. A cycle race across America is 3,069.25 miles in length. Juan knows his average speed for his previous races is 15.12 miles per hour. For For the next race across America, he'll cycle for 8 hours per day. Estimate how many days Juan will take to complete the race. So in this question here, the key word here is estimate, okay, because I cannot possibly work this out without a calculator. So I'm going to estimate, so that means I'm going to round these values to one significant figure each. So let's round this number to one significant figure, that to one significant figure, and that is already one significant figure anyway. Okay. Then I'm going to use the formula of time equals distance divided by speed. So rounding those units, rounding those values gives that there. Time equals distance divided by speed. Time is 3000 divided by 15. Okay, and that gives me 200 hours. So 200 hours, but this wants the answer in days. Okay, and if he just cycles for 8 hours per day, because obviously he needs to rest and sleep, so 200 divided by 8 gives me 25. Okay, and you can see that working out from there. So that is 25 days, and that is 3 marks for that question there. Part B for the question asks whether the answer in part A is affected if the average speed increases. So it is affected, and it's affected by it taking less time, because obviously if he's cycling faster, it will take less time for him to cycle. That question there is 1 mark. The whole question there is worth 4 marks. So question 6. Sean drives from Manchester to Gretna Green. He drives at an average speed of 50 mph for the first 3 hours of his journey, and then the second part of that journey, he's got 150 miles left to drive, and he drives those at an average speed of 30 miles per hour. His average speed, he says that his average speed from Manchester to Gretna Green was 40 miles per hour. Okay, so is he right? And you've got to show how you get your answer. So the way I'm going to approach this question is I'm going to underline the key information first, then I'm going to find the distance for his first part of his journey, and then the time for his second part of his journey, and then I'm going to find his average speed. So these are my steps in this question here. So I've underlined the information. Let's find his distance for the first part of his journey, okay? Because I'm given his speed and I've given the time taken. So the distance is simply the speed times the time. The speed is in miles per hour, 50 times 3 hours, which will give you 150 miles. So that's a distance, okay, 150 miles. So that's the distance of the first part of the journey. Now let's find the time for the second part of the journey. Okay, the time for the second part of the journey, we're told in that second part of the journey he's got 150 miles, so the distance is 150. The speed is 30 miles per hour, so 150 divided by 30, which is 5 hours. Okay, so that's 5 hours. Now, I now know the distance of the whole journey, because there's 150 miles for the first part, 150 miles for the second part, so that's the distance of the whole journey, and I know the time for the whole journey. I know the time for the first part of the journey, and I know the time for the second part, which I've just worked out. So that's going to be 150, add 150, which is the distance, divided by 3, add 5, which is 8 for the time. Divide those through, and you can see how I've done that here using the bus stop method, and that gives me 37.5 miles per hour. So was Sean right? He said his average speed was 40 miles per hour. He was actually wrong. Okay, he was actually wrong. So you'd have to state that fact, and with you working out as the evidence. So that there is 4 marks for that question. Question 7. James and Peter cycled along the same 50-kilometre route. James took 2.5 hours to cycle that distance. Peter started to cycle 5 minutes after James had started. He then caught up with him when they both cycled 15 kilometres. They cycled at constant speeds, but obviously they weren't the same speed. Okay, so work out Peter's speed. So in this question here, I'm going to first of all find James's speed using the information given here. Then I'm going to find James's time to cycle 15 kilometers, okay, using that distance there. And then, since I know then what Peter's time was, I'm then going to find Peter's speed, okay. So let's do that now. First of all, let's underline the key information. There's the key information. There's the steps I'm going to take. Okay, and let's do those now. So, James's speed is given by speed equals distance divided by time. The distance was 50 kilometers. Time is 2.5, which as a decimal in hours is just 2.5. Okay, then to work this out without a calculator, I'm just going to multiply. I'm just going to find an equivalent fraction by multiplying the top and bottom of that fraction by 10 and then dividing through, because I prefer to divide whole numbers than decimals. So that's 20. Yeah, that's 20. So James's speed was 20 kilometers per hour, and that's a reasonable answer. Part 2, I need to find James's time to cycle 15 kilometers. Since I know his speed, I can now find his time to cycle 15 kilometers. Well, his distance is 15 and his speed is 20. So if I just do 15 divided by 20, okay, that would give me in hours his time. And that is obviously 3/4. If I simplify that, it's 3/4 of an hour, which is clearly 45 minutes. That's 45 minutes. Okay. Now, the reason I've turned it into minutes here is because in the next part of my answer, okay, it says that Peter started to cycle 5 minutes after James had started. So if I'm going to find Peter's speed now, it didn't take Peter 45 minutes. It took him 5 minutes less, which is 40 minutes. So now Peter takes 40 minutes, okay, to cycle those 15 kilometers. So using speed equals distance over time, here's my distance, 15 kilometers for Peter. Okay, time is 40 minutes, but if I convert that into hours, which is what I need to do, I need to divide it by 60. So 15 divided by 40 divided by 60. So I need to work this out without a calculator again, because it's a non-calculated question. So to calculate that, what I'm going to do is I'm going to divide this whole number by that fraction there. So I'm just writing this with a denominator of 1. And then to divide two fractions through, I need to multiply the first fraction by the reciprocal of that second fraction. Okay, so that gives me 900 divided by 40. If I simplify that fraction, I get 90 divided by 4. To divide something by 4, I can just half it and half it again. That gives me 22.5 kilometers per hour. So remember, in the first part of the section, I'd worked out James's speed as 20 kilometers per hour. I've now calculated Peter's speed as 22.5 kilometers per hour. I'm just checking now, is that a sensible answer? And yes, it is a sensible answer. We know that Peter would have cycled slightly faster because he caught up with James. Okay, so they're both reasonable answers there, but that final answer there and all the working would give you 5 marks. Question 8. On Monday, Tariq travelled by train from Manchester to London. Tariq's train left Manchester at 8:35. It got to London at 11:05. The train travelled at an average speed of 110 miles per hour. Okay. Then I've got some more information about a different person. But this time, Jill travelled the same journey, although she had to travel an extra 37 miles. Okay, and her train was diverted, so it got there slightly later. Work out the difference between the average speed of the two trains. So in this question here, I'm going to find the distance travelled by Tariq. I'll find that distance since I know the time and know the speed. So I'm going to find the distance travelled by Tariq, then I'm going to find Jill's speed, okay, and then I can find the difference in those speeds. So let's underline the key information here. Here's the key information. And also what I've done here, before I do anything else, I've converted this difference in those times into hours. So from 8:35 to 11:05, that's 2.5 hours. And from 8:35 to 11:35, that's 3 hours. Okay, so I've just noted that down. Okay, so now what I'm going to do here is, first of all, I'm going to find the distance travelled by Tariq. So here's the first part. I know the speed he travelled at, which is 110 miles per hour. I know the time he took to travel, which is 2.5 hours. If I multiply those two, I'll get the distance, which is 275. Okay, and you can see that from my working here. That's 275 miles. Now, part 2, Jill's speed. Now, Jill has travelled a distance of exactly the same as what Tariq travelled, plus an extra 37 miles. Since I know Tarik's distance here, I can then add 37, and that's her new distance for Jill. If I divide that by the number of hours she's taken, I can find her speed. And so her speed is 312 divided by 3. As you can see here from the short division, it's 104. And then lastly, the difference in speed, well, that is subtracting 104 from 110. Okay, because Jill's 104, Tarik's 110, so the difference in speed is 6 miles per hour. 6 miles per hour. So that whole question there is worth 4 marks. Okay, question 9. Find the pressure exerted by a force of 900 newtons on an area of 60 centimeters squared. Give your answer in newtons per meter squared. So the thing you have to be careful of here is that this is in centimeters squared, but the answer I need should be in newtons per meter squared. Given a formula here of pressure equals force divided by area. So using that formula, what I'm going to do is I'm going to underline the key information here. Then I'm going to substitute into that formula the force of 900 and the area of 60. That will give me 900 divided by 60, which is 90 divided by 6, which is exactly 15 newtons. This is newtons per centimeter squared. Newtons per centimeter squared, since I've used an area of centimeter squared in my calculations. Now, all we've got to do now is convert this into newtons per meter squared. If I'm going to convert it into meters squared, I know there's 100 centimeters in 100 centimeters in a meter, so it's going to be 100 centimeters squared in 1 meter squared. So divided by 100 squared, I'll get 0.015. 0.0015, and that whole question there is worth 2 marks. Question 10. So here's two solid spheres, A and B. Sphere A is made out of gold, sphere B is made out of silver. Sphere A has got a radius of 2 centimeters, B's got a radius of 3 centimeters. Okay, and I'm also given here the volume, the formula for the volume of a sphere, 4/3 pi r cubed. Okay, the gold has got a density of 10,000 kilograms per meter cubed. Which sphere has got the greatest mass? You must show how you get your answer. This whole question is worth 4 marks. So there's 4 steps for this question. The first thing I'm going to do, I'm going to underline the key information here. Okay, so I've underlined the key information here. And what I've also done, okay, is I've converted all of these into standard form. I'll convert them into standard form because it just makes my calculations easier. If you're struggling with standard form and how these are written, look through the standard form booklets on mathsupgrade.co.uk and look at the video clips on my YouTube channel, and that should support you. But essentially, the radius of this sphere is 2 centimeters, which is 0.02 meters, which is 2 times 10 to the negative 2 meters. Okay, and the density of gold is 1.9 times 10 to the 4 kilograms per meter cubed, and the density of silver is 1 times 10 to the 4 kilograms per meter cubed. Now, these are the steps I'm going to take. I'm going to find the volume of sphere A, since I know the radius of it. And then I'm going to find the volume of sphere B, again, because I know the radius of it. Then I'm going to find the mass of sphere A, since I've worked out the volume, and I'm given the density. Similarly for sphere B, I'm going to find the mass, since I'm given the since I've worked out the volume and I'm given the density. So let's do that now. So the volume of sphere A, the volume is given by 4/3 pi r cubed. That's 4/3 pi times 2 times 10 to the negative 2 cubed. Non-calculated question. So I'm going to cube this in brackets, which is 8 times 10 to the negative 6. Again, look at the standard form booklets and video clips. We need support with this. Okay, so that is the volume of sphere A. I'm going to leave it in that form, okay, because I cannot work out the value of pi, because it's a non-calculated question. Now, the volume of sphere B, in a similar fashion, I'll work it out over here. Now, let's find the mass of each of those spheres, and then we can compare which has got the greater mass. So here's the mass of sphere A. The mass is given by density times volume. Okay, You should know that formula because it's not given to you in the question. So the density is 1.9 times 10 to the 4, as given in the question there, times by the volume, which I've worked out just above it, and that would give me 0.152 times 4/3 pi. Okay, I cannot work this out exactly because I don't have a calculator, but that's what it would give me. Similarly for sphere B, the mass is given by the same formula. Substitute in those different values, and you get 0.27 times 4/3 pi. Now I need to work out which has got the greater mass. Which got the greater mass? Well, if you can compare these two values, okay, even though they're in terms of pi and with 4/3, you can see that sphere B has got the greatest mass. Okay, so that is what you need to do for those 4 marks of that question. Again, if you struggle with that question, look through on my booklet and video on standard form, and that should support you further. There's also a video clip and booklets on compound measures on all of the calculator questions. Okay, so make sure you attempt that as well.